Spring fans, welcome to another installment of Spring Tips. In this installment, we're going to look at the new OAuth client support in Spring Security 5. Now, in a previous installment, we looked at Spring Security OAuth, and we looked at the OAuth authorization server that you could create pretty easily using Spring Security OAuth. Now, that support, that fundamental support inside of Spring Security OAuth has been there for a while, and for those who are playing the home game, it can be kind of confusing to sort of figure out where we are in terms of the OAuth picture and Spring. So let's have a quick review, right? Well, it all started with Spring Security OAuth, which is a third-party project, a community project that we then brought into the Spring portfolio, and we've developed pretty consistently since 2011. That project has then gone on to underpin the UAA, the authorization server, the identity provider that we provide for Cloud Foundry, our open source platform. So that component has been battle tested at scale by enterprise customers for years, 5-6 years now in production. The UAA is a hub, if you will. You can use it to talk to other things like Active Directory and so on. Now, that is an open source project, and the 90% of that work that's in the UAA is back in the Spring Security sort of OAuth project, right? That project has always had several different bits. It's the ability to stand up an OAuth server and the ability to act as a client to an OAuth service. And that's important. When we talk about OAuth, the client is arguably the most important part of the protocol. OAuth, of course, is a protocol for authentication delegation. There are three different pieces that we care about, or actually I suppose there's four. There's the authorization server, the thing that vends tokens that we can then use to then make requests of other resources that are protected and require those tokens. So that's a REST API, maybe the Facebook friend graph, that kind of thing, the Twitter timeline API. These different APIs require tokens, so we call them resource servers. Okay, so the authorization server vends resource server authorization and access tokens that then can be used to talk to resource servers. A client is the one that bears that token on behalf of the user. So you have a user driving a client, and there can be one user and multiple clients. You might have, for example, Facebook on the iPhone versus Facebook in the HTML5 browser versus Facebook on the Android device. All three of these are different client experiences, but it's fundamentally, ultimately, me who's driving that experience when I log in as my Facebook profile. Or Twitter profile or whatever, right? These four pieces make up the topology of an average OAuth architecture. Now, as often as not, we are used to thinking about the resource server and the authorization server as being the same thing. When you think about Facebook, it's the same set of APIs. You get a token from their OAuth APIs, and then you use that token to then call the Facebook friend graph. But there is no reason that this has to be. You could, for example, use a OAuth token, an access token from an authorization server to then call some other third-party service, or to call another resource service, right? So you may delegate authentication, in this case as a resource server, you may delegate authentication to some other thing when you do that. Now, Spring Security OAuth, in turn, was we saw auto-configured support for it in Spring Boot, so you could use Spring Boot to auto-configure OAuth clients. And then going a step further, there are some other use cases related to protecting resources and to perpetuating access tokens that we saw auto-configured in Spring Cloud, which built upon the support in Spring Boot. And that's basically the story that we've had so far, up until Spring Security 5. So Spring Security 5 is the first release of Spring Security to come after Spring Framework 5, which itself introduces one major theme, which is the new reactive programming support, and a number of other smaller things. The reactive programming in of itself would be enough, I would think, to justify a brand new Spring Security release, but never content to sit on their laurels, the Spring Security team have two major features that are in this new release, with much more to come in 5.1. The first major feature is integration and support for reactive programming in Spring Security 5, and that's a whole other Spring tip. And then also support for OAuth. There's some other really nice features as well. There's support, for example, there's a new password encryption sort of hierarchy there that's really kind of convenient. There's a lot of nice stuff there. There's improved testing support, so a lot of convenient features in Spring Security 5, but the two big ones are this new support for acting as an OAuth client and the reactive programming support. And in this installment of Spring Tips, we're going to look at the OAuth client support. Now, when I say client, again, we've already talked about in a previous installment how to stand up a Spring Security OAuth authorization server, and I've got something that's basically similar to that running in the background here. I'll leave it to you to consult the code in the Spring Tips Git repository for Spring Security OAuth, Spring Security 5 OAuth client. There's a repo there under the github.com/spring-tips org. And there you'll find the authorization server that I'm using for this example, which we've mostly covered in a previous installment anyway. But the important thing to understand is that you don't have to use the Spring Security OAuth authorization server with the Spring Security 5 authorization client. So we've got this OAuth client support in Spring Security 5. We've now that we supersede in this way most of Spring Security OAuth. That separate project has now been folded in to Spring Security, and because we have this client support, we can use it with Spring Security itself, just as a regular library inside of Spring Security. And as I was saying, that support doesn't need to be used with an OAuth server that we provide. It can be used with any OAuth server, right? And when you talk to OAuth servers these days, there's going to be, at the very least, there's going to be OAuth. Usually, as often as not, there's OAuth 2.0, but historically there have been OAuth 1.0 and 1.0a, and now there's 2.0. And then going further, extending that, you've got other sort of layered protocols, if you will, or layered prescriptions for things like OIDC or OpenID Connect, right? This is a standardization of things like which endpoint provides the profile and the name that's used to identify the principal and the structure that comes back from the user info endpoint. Subtle things like this, and JWT, JSON Web Tokens, and which this standardizes the payload of the access token itself, right? So a lot of stuff here to appreciate, and you'll have to contend with these nuances in these different OAuth clients. But Spring Security's OAuth support, the OAuth client support, can manage and work with all of these different types of technology. So you can use anything, right? And you can use Facebook, you can use GitHub, you can use Google, you can use a third-party authorization server, something like Okta. Okta is a company, OKTA. They're a company that provides an authorization server, and it acts as a sort of hub. This hub is it's a front end that then delegates to other identity providers. So you could configure the hub to talk to Active Directory or to LDAP or whatever, or you could just manage it, your profiles, your users in that system itself, in Okta itself. Either way, it can vend whatever protocol you want. So it'll speak SAML, it'll speak OAuth for the clients and so on. So that's one option. You could certainly use that, and that's a very common choice. You could also use a third-party authorization server. So there's a Keycloak from the folks over at Red Hat, which is a very nice tool to use, and it has good support for Spring Boot apps and so on. So that might be worth a future installment at some point, I think. But either way, Keycloak and Okta and the Spring Security OAuth authorization server and Google and Facebook and Twitter and LinkedIn and literally thousands of other authorization servers out there all work in basically the same way, and you can use them all from this new client support. So let's do that. Let's build a OAuth 2 client. We're going to use the Lombok compile time annotation processor. We'll use Spring Security and the web support. And I think, that's kind of it. We've already got an authorization server running. At least I think we do. Let me check. Yeah, we've got it running here. And the important bit to understand is that I've hard-coded 3 users in this authorization server: Josh, Rob, and Joe. Obviously, this is Rob Winch and Joe Granja, right? Rob Winch is the lead of Spring Security, and Joe Granja is the sort of lead of the efforts that brought in the OAuth support for Spring Security 5. So both of them have just done an amazing job in this new release. I'm really grateful for all their help they've given me in kind of making this stuff work for my example here today. So thanks to both of them. And they, of course, I should absolutely underscore that they would not approve of a default password of PW. But I want to make it simple for my demo here, friends. So I'm going to use username is Rob and Joe and Josh, and the password is PW. All right, don't do that at home, but makes the demo simpler. Okay. So we're going to build an OAuth 2 client. We've generated the zip file there, And I'm going to go now to the downloads directory here. I'm going to open this up, UAO OAuth 2 client. And this client is it's a regular web application, and we want it to act as a client to our authorization server to get access to a resource server via the access token that we get from the OAuth client. Well, this resource server that we're going to stand up that we're going to talk to rather, is actually the authorization server as well. The resource server is this. It's this endpoint here called resource user info. So if you're using OIDC Connect, there's a standardized endpoint that the authorization server is supposed to expose that provides a profile. Well, here we're going to provide that we're not using OIDC Connect, we're just using OAuth here. So we're going to provide an endpoint here that provides a JSON structure. Basically, we're going to take a map and serialize it. It'll provide a JSON structure that has a name attribute for the principal name. Now, is this a particularly interesting thing to get? No, but we need to configure that this be secured. That's what this bit down here does. And we're saying if this endpoint is accessed and somebody tries to access it and doesn't have the scope profile, then reject the request. If it does have it, it'll return the JSON structure showing us the name. So you could create a REST API, a Spring Security, REST API, and then secure it using the Spring Cloud Security Resource Server configuration, and have that then delegate or reject any requests that don't have an access token, right? So we want to call this endpoint. This is the server side, if you will. We're going to act as a client to this endpoint, right? So as a client, I want to be able to get a token that will allow me to make a call to this resources user info endpoint. Now, even though they both live in the same code base and in the same process, they could be two separate things, right? I would just want to stress that these are two logically separate things that just happen to be running in the local machine here. Okay. Now, in order for me to configure a client, I need to do some some YAML foo here. So I'm going to go ahead and use YAML because it's a hierarchical and it makes this kind of configuration just a bit easier. So we're going to say application.yaml. And there, we're going to have to configure the Spring Security OAuth client registration. Now, when we talk about registration, we have to tell our Spring Security client support about the clients that we're going to talk to, that we're going to expect to be able to use. So we give it a logical name that we care about locally, login client, and then we have to specify things like the provider, which is which authorization server are we using, what endpoints should we call for things like the token, the user info, the authorization, etc. All these different endpoints could change. They should all produce consistent responses based on the protocol, of course, but the endpoints themselves may change based on context paths and whatever. So we have to spell that out. Now, I want to underscore that we're going to be using a custom authorization server. So I'm going to over-specify things here. In common cases, such as with Google and GitHub and Facebook and Okta and so on, there are already pre-configured clients for you. So these things like the authorization URI, the token URI, all that kind of stuff, it's already pre-configured for these common cases, in which case you don't need to worry about that. These providers are just available for you. Now you can see here, of course, that I've got this new application, and it's registering these types on the class path. The class path, the types are read in my IDE, so that tells me that we need to add a few dependencies here, right? So what we're going to do is we're going to go to the Maven pom.xml and add 2 bits that we care about here. We care about the Spring Security OAuth 2 support. Goodbye to that. And we want also the Spring Security OAuth 2. Okay, yours. Good. All right. Okay, so let's see. Good. Okay, so we have those bits on the class path. So that should be it. Oh no, OAuth 2. No, I'm sorry. I always get that wrong. OAuth 2 client. That's what we need. So we're going to add that bit plus the, I'm not sure how to pronounce this, Joe's something, support. Add that to the class path, and common OAuth to provider. Uh-oh. What else am I missing? We have Spring Boot Starter Security. We have the OAuth 2 client. We have Joe's. So we have the web support. Maybe we just need to tell the ID about it. Maven. Reimport. That's a bit of a bummer. Oh, there we go. It was cached. So now, here are all the types that I expected. That's weird. So usually the IDE is a bit faster to update itself, but it seems to be okay now. So good. So now we go back to our client configuration, and we need to tell the Spring Security client support about the client, right? So we're going to do that here using some configuration. So the configuration needs to point to a provider of some sort, and we're going to configure that provider in a second, right? That provider support. We could actually do that, here, for example. I could create a provider section, and we could come back to that in a second. But for now, we're going to give this a name. The provider will be called local auth z, and we'll reference that here. We'll say local auth z. So that's going to be our local provider. And then the client itself, there's several things we need to specify. The ID, client ID, is the ID that we've registered the client with in the authorization server. So a lot of websites like Facebook, for example, and Twitter, they'll have a developer page or portal where developers can sort of self-service register clients. And when they do, they have to give it a client ID. They have to give it a client secret like this. So client secret will be just secret in this case. I have to give it a client authentication method basic, right? This is and I'm over specifying a lot of stuff here, right? In most client examples, you're not going to have to specify the authentication method, for example, or, this kind of thing, authorization code, right? A lot of these are just going to be assumed and understood for you by default. The scope that we want is profile. Again, if you're using OpenID, it'll have to be OpenID, right? So client name is our logical name for the client. How we want it to appear in any of the white label pages and so on. The redirect template. So we have to send this request to a endpoint. Redirect URI template base URL login /OAuth2 /code /registration ID. All right. So there's our redirect URI template, and this endpoint this is what we're expecting the client. We're expecting the service to redirect when it's done with the OAuth authorization flow. We're going to expect it to redirect to our application, and our application, we're going to fill out the host and port. It'll get automatically filled out here for us. We'll have a filter that will listen on login OAuth2 code, and then it'll look for the last bit here, the path variable, registration ID, and it's expecting that to match this login client. Okay, so we have those bits there. Now we need to go back and configure that provider. So authorization URI is going to be equal to HTTP auth server :8090. Now I've got that running application. I told you I've got this application running on the same host and port, right? So if you see here ping auth server, I've got that running on. I've got etc hosts. I've just got a little line in my etc hosts that points to auth server. So here it says 127.0.0.1 localhost auth server, and then I've got another domain here as well. But the reason I have it a separate domain, a separate host name, is because the Spring Security authorization server is going to provide cookies, and so is the Spring Security client, right? So that client is going to have a cookie, and so is the authorization server. And remember, cookies are keyed by the host name, not the port, but the host name. So if you have two different cookies coming from the same host, they might trample one another. So we want to make sure that they're separate hosts now to avoid that problem, right? So it doesn't have to actually be a DNS host. It can just be etc hosts, for example, which is DNS, but I mean it doesn't have to be complicated, right? Very, very simple to get this working. So okay, we've got to provide the authorizations URI. So in our case, the authorization server has the OAuth authorize endpoint. The token URI is, let's just copy and paste some of this here. Okay, and the auth server token URI is OAuth token, and the user info URI is OAuth, sorry, it's resources user info. So this is the endpoint that we're gonna call later on that has this is the resource server. That's the bit that we care about. That's non-standard in our case, but it would be, for example, if using OIDC. So username attribute, and that's the name that we get back from the JSON stanza that we expect to be able to identify the principal. So Rob or Joe or Josh. Okay. So now let's run this application. We have nothing written in code. We've done absolutely nothing in terms of code, but already we should have a valid client. So let's just see if that starts up without issue, and then we'll use that configuration to do our work. Uh-oh. Okay, that looks okay. So looks like we've got a filter chain, we've got a default username and password. Okay. So good. So that would seem to be all we need for our client. Now again, you could have as many registrations as you want. You could have a foo client and you know, so on. You could have as many registrations for clients and for providers as you'd like in this YAML file. And of course, this stuff could be loaded from a database. Of course, there's an interface. So this is ultimately these registrations, these client registrations, get turned into objects of just that type, registration, right? This is this is the property. Sorry, it's called client registration. Here we are, client registration, blah blah blah, and client's configured condition. Where are the beans? So it gets mapped into a in-memory client repository, and we have objects of type client registration, right? So where are those bits? That's I am not inspired by IntelliJ's not seeing these types. So let's make sure I've got the right types on the class path here again. Spring Sec. Oh, is that right? Security. I knew I did something obviously wrong. Okay. Okay. There we are. So it's actually Spring Security. Here I'm all excited about the merged support for Spring Security OAuth in Spring Security, and I go and give it the wrong group ID pointing to the old Spring Security OAuth group ID. Don't do that. It's actually Spring Security OAuth. Okay. So now client registration, which actually that invalidates my previous run. So let's go ahead and run that application again this time. And while that's happening, let's see if client registration is on the class path. There we are. Okay. So our previous run did not work. Good. So that means that there's a bean of type that we haven't configured. Authorization URI can't be empty. Okay. So that's the error that we have there. We need to configure authorization URI. Fix the typo. All right, so that looks like it's happy. Good, and we got the right types on the class path, and it hasn't printed out a default username and password, which means that Spring Security has detected the OAuth stuff. So that's all very good, and we can actually now go back to that type that I was going to show you a second ago, client registration. And here we just have a type that produces, you know, that holds things like the registration ID, the client secret, etc. All of these are, you know, this is all. You can see the default is basic, right? For example, so a lot of this stuff is kind of obvious. You can register custom client registrations if you want, right? There's actually a client registration repository, and that repository is the thing that must be aware of your client registrations. But there is no reason that this client registration repository has to be the default one. You could have one that's based on a database, for example. Okay, so a lot of different options here, a lot of different interfaces that you could use to make this work easier. Now, we have that auto configuration in Spring Boot, which we're using to take your properties and to turn them into configuration. But there's absolutely no reason that you that you have to do it that way. All right. Now, moving on. So we're going to build an application, and we're going to talk to that REST API. We're going to talk to that resource server, the profile endpoint, using our newly minted access tokens, which we have to obtain. So let's go ahead and try and do this. Let's create a REST endpoint here on the client called class profile REST controller. Okay, and we're going to create an endpoint here that returns just the details that come back from the profile endpoint. Now that detail is just going to be a class principal details. It's going to have a field here, string name, and I can use lumbuck here to make short work of this. So null args constructor. All right, so there's my very, very simple type. I'm going to return the principal details when somebody logs in. So details or profile, okay? And in order to do this work, we're going to take advantage of the OAuth 2 authentication token. So here's my token that gets injected. That's the principal that will be hydrated by the time this endpoint gets called. So the first time around, when this application starts up, we're going to hit this endpoint, and it's going to redirect to the login filter. It'll redirect to the auth server. So we'll never hit this endpoint without this token. It'll force us to redirect and to authenticate. Okay. So what we're going to do is we're going to take advantage of the token to get the access token. So we've got an authentication token. We'll use that to get the access token. In order for us to do that work, we need to use the OAuth 2 authorized client service. So private final OAuth 2 authorized client service, injecting this into the application. And we'll say return this.client-service.load authorized client, and we'll use the token .get authorized client registration ID, token.get name, and this gives us a client service, or authorized client rather, and the client we can use here. Let's clean this up a little bit. We can use the client to then ascertain information about the application. So the user info URI, we can get that from the client, right? So client get client registration dot get provider details dot get user info endpoint. That's the endpoint that we want to call. So we're getting the URI here of the user info endpoint. Okay, so that's the URI, and now we need to make a request with this client, with this information from the user info URI. We're going to make a request to that, but we need to have the token in order to do that. So we need to have the access token to do that. So we could in this code in line, obtain access token, and then configure a REST template call, an HTTP request entity. We could configure that here manually if we wanted to. But instead, I would prefer to change the REST template that we use. We're going to make a call using a REST template. So let's configure the REST template and then inject that into the constructor. So let's configure a REST template up here and use that REST template to make a call in a secured way. So we're going to say new REST template builder interceptors. We're going to provide an interceptor, and the interceptor we're going to provide is a client HTTP request interceptor. And the code that we're going to use is fairly straightforward. Again, we're going to also inject that OAuth 2 authorized client service, OAuth 2 authorized client service, and the filter is fairly straightforward, right? So we're going to say take the client request, execution, say execution.execute HTTP request, bytes, etc. And we're going to respond. We're going to go ahead and now add an access token to the headers of the request that's being sent by this REST template. Okay, so we'll first of all get access to the current authorized authentication token, right? OAuth2 .class.cast, and we're going to look at these current static reference to the current token, right? The context local token. And we're going to cast it to OAuth 2 authentication token. Now, this is probably not the smartest thing to do. This might be a different token when you use it. So if you have different types of authentication possible in your application, you should definitely do an instance of before you do this. But in my case, I know that unequivocally it's going to be an OAuth 2 authentication token. Now, I've got this token, and from there, I want to get the client, so I can do the same as before. I'll say OAuth 2 authorized client equals CS load authorized client, and I'm going to use the token dot get the authorized registration ID, token dot get name, and then we use the headers. We're going to change the headers. We'll say HTTP headers dot add or set authorization. I guess we can add it ourselves. Add HTTP headers dot authorization bearer plus the client access token. So client dot get access token dot get value token value. All right. So there's our custom header. A custom bearer header, and we're going to then proceed with the request. This of course can be replaced with a lambda. So there we go. There's our REST template, and it is going to, look up the current authentication token. We have to do this manually, right? I'm doing this using the security context holder here because we have a bean being processed outside of a request. Notice that I can get access to that same token as a resolved argument in my Spring MVC handler method. So this works just fine if I wanted to write that code here. But if I want to get access to it independently, I can do the same thing as well, because it is ultimately just coming from this security context holder dot get context dot get authentication. All right. So now let's see. We have this configuration. I have the client here, and I have the URL. Now I want to write that request to the downstream service. I want to make that request to the downstream service. I'll say this.rest template dot, and we're going to use the exchange, and we're going to say that we want to make a call to the user URI, user info URI. It's going to be an HTTP GET call. There's no body, so we'll say null. And then the type of data that we want to come back is of type principal details. So let's see what we get when we save all this. Response, okay, so we're going to say return response entity get body. All right, there's our call. Not bad. That's basically all it takes. So let's go ahead and see what it looks like when we run it end to end. Okay, so we've got a filter, got a REST template that's been customized here. We've got a filter. It's an OAuth aware, so it'll make OAuth authenticated calls. We might rewrite this code to say, oh well, if you don't have this, then just return a regular, just execute. So we could actually say if this is null or something like that, or if there's no authentication, then just proceed without it, right? So it could be a regular REST template, and we'll just skip all the getting headers and adding them and so on. Okay. All right. So the application's up and running on port 8080, localhost 8080 // and we hit login client. Now notice that I am now. I was on the when I go back to this page, localhost 8080 / login. Even though I hit enter to / it redirected to login. Now if I click on this, it says login client, right? This is the logical name that we gave, in the configuration, the client name, not the client ID. The client ID is localhost 8080 / OAuth2 / authorization / login client. When I click on this, it's going to redirect to the authorization server, right? That filter is looking at the request and saying, oh, you want me to redirect you to the authorization server, which lives on host and port auth-server :8090. So different host, you can see it's a different server. I'm using the white label pages for both the authorization server and for the client, right? So both are just very, very sort of uninteresting pages. You can and should customize these to match the skin that your application is expecting, okay? So here, remember, we've got Joe, and password is PW, all right? So let's hit login. It's asking me, do I want to allow or to authorize client 1234 to access my protected resources? This might be the the equivalent of the Facebook friend page, or the Facebook page where it says you want to allow this third-party website to have your profile, your friend graph, whatever. And you can see this is valid OAuth flow here. But the authorization, this is part of OAuth. The authentication is non-standard, right? The authentication, I just happen to log in using an HTTP form on my authorization server. But that isn't, that's not necessarily the same thing as OAuth. That's not OAuth itself. I could have logged in any number of different ways and then redirected back to this OAuth flow, okay? So let's say authorize, and there we go. It redirected me back to this, to the client. I hit the / endpoint, and we got the profile information, right? So I'm logged in, and now whenever I make a request, if I make any requests in this endpoint, and I use that REST template, it's going to add this header, and this header will authenticate me. So now I can call any other API that expects, any other resource server that expects that token, and it'll work. All right. Now, we've looked at some of the client support in Spring Security 5. We looked at how to configure one fill out everything, how to configure everything. You don't have, we couldn't take anything for granted. So we configured the provider and the client itself, and we could configure all the details. And hopefully you won't have to do this more than once or twice, right? You can get it right. It can also be convenient to configure a filter and configure a REST template and put this in auto configuration. And you might even have information about which OAuth clients to call being loaded from a database, for example. So there's no reason that this couldn't be just automatic. You have an application that talks to a well-known database, maybe in your organization, and you have the right auto configuration on the class path, and then when it starts up, it'll connect, and you'll have automatically authenticated REST templates able to talk to these resources, using the authorization server. So all that can be very, very easy. I did it the hard way here, and I expect that we'll eventually have the ability to this will just be automatically contributed for you going forward. I expect that this is one of the things that'll be nice to have going forward. There is actually an OAuth REST template, for example, from Spring Security OAuth, but increasingly that is less and less useful, right? It'll be nice just to be able to have a filter automatically contributed to my regular REST template like this. So we looked at Spring Security 5, we looked at configuring custom clients, we looked at configuring everything that you need to talk to an authorization server, a custom authorization server like the Spring Security OAuth-based authorization server, which underpins UAA and Cloud Foundry. And we've also looked at how this is just one of many choices, and you could look at the common OAuth 2 provider definitions here, and you'll see that there are common ones already provided for you, so you don't have to worry about that if you are just connecting to one of these big four, with more to come, I'm sure. We also looked at how to use the API, how to use the API itself, the OAuth 2 authorized client, the OAuth 2 authorized client service. These are APIs that are in Spring Security itself, and they give you kind of a repository, a runtime API that you can interact with to understand which clients you've got, and to interrogate them and get information about them. So all this is managed for you by the framework, and there's a default in-memory version, but that could, of course, be based on the database. We haven't really looked at testing, for example. So testing is a thing that you can and should do. Ultimately, when you write this test is going to be using the standard Spring MVC, mock MVC test client, and there you have a builder. There's some test filter. There's some static methods available on a type in Spring Security that gives you the ability to say, okay, run this mock client request with this current authentication, and you can easily mock out this authentication token, and then when you test your code, when you test your endpoints, it'll have access to that token. This code will still work. It'll just be a mock token. All right, my friends. With that, I hope you got something out of this. Thanks for watching, and we'll see you next time.